Here's an explanation for the answer to final exam question number 55 in Teach Yourself Electricity and Electronics, 5th edition. Please refer to page 673. The question asks us about an enhancement mode metal oxide semiconductor field effect transistor. That's what MOSFET, the acronym MOSFET, stands for. It gives us 5 possible characteristics of an enhancement mode MOSFET. Which one makes for a true statement? Well, the correct answer to this question is E, as in echo. It requires the application of a bias voltage at the gate electrode, that's this G here, in order to produce a channel. Now here's what an N-channel enhancement mode MOSFET looks like when there's no bias on the gate at all. The source has a negative voltage, the drain has a positive voltage, normally provided by a battery or a power supply. The gate, if it has no bias at all, results in no channel and therefore no conduction. This P-type semiconductor material will not allow conduction unless we apply a small positive bias at the gate electrode. When we do that, what we get is a channel that in effect behaves like a region of N-type semiconductor. That's why we call this an N-channel enhancement mode MOSFET, even though the predominating material is P-type. When we apply this positive voltage here, we end up with a N-type region, and the greater the positive voltage that we apply, the larger that N-type region will get, and the better the conduction will get between the source and the drain. So once again, the correct answer is E, as in echo. In an enhancement mode device, you have to apply a bias in order to get a channel. Contrary-wise, in a depletion mode device, it already has a channel, and when you apply the bias of the correct polarity, you actually make the channel smaller. That's why they call it depletion mode. It produces a depletion region. If we had a P-channel enhancement mode device, we would simply reverse these symbols. This would be an N-type piece of semiconductor material, and the polarities, of course, would also be reversed. All of these polarities would be reversed. So, but otherwise, the principle is exactly the same. We would then have to apply a negative bias to cause a P-type channel to form. That is how a P-type enhancement mode device works. To review how enhancement mode devices work and what the symbols for them in circuits are, you can go back to page 397 in the book. Page 397. But once again, the answer to this question number 55, E, as in echo.